So, NVIDIA just dropped its next generation AI platform, and it's called Rubin. But listen, this is not just another story about a faster chip. What we're looking at is a total reinvention of the supercomputer itself. They're changing the game from focusing on tiny parts to building one giant, incredibly powerful system.
Right out of the gate, NVIDIA is making this incredibly bold claim. The entire rack, the whole cabinet, is now the computer. We're not talking about individual servers anymore, not even individual GPUs. We're talking about one massive distributed accelerator. Okay, so let's dive into what that actually means.
So why the big shift? Why do this at all? Well, the simple answer is that we're hitting a wall, a very real physical wall. In the AI servers we have today, every single component, the GPU, the CPU, the networking, even the power delivery, everything is being pushed to its absolute physical and thermal limit. The real bottleneck isn't just about making the silicon faster anymore. It's the insane complexity of trying to get all these limit-pushing parts to work together.
And this image, it just perfectly illustrates how we got here. Back in 2016, a top-tier AI system like the DGX-1 was basically one box, one powerful server. Fast forward to today, and we're dealing with entire racks packed with dozens of GPUs and CPUs. The scale of the problem has just exploded, and it became obvious a totally new approach was needed.
NVIDIA's answer to this whole mess is a strategy they're calling extreme co-design. Now think about this. Instead of just designing a killer GPU and then letting other companies figure out how to build a system around it, NVIDIA is now designing everything, and I mean everything, as one single unified product. The silicon, the networking, the power, the software, even the metal chassis it all sits in, it's all engineered together, right from the very beginning. And to pull this off, NVIDIA is rolling out an entire family of new silicon under this Rubin platform. You've got the Rubin GPU, of course, then there's the Vera CPU, the NVLink 6 switch to let them all talk to each other super fast, and then you have the Connects, Bluefield, and Spectrum chips handling all the networking. By controlling every single one of these key pieces, NVIDIA gets to dictate the entire system architecture. Okay, but here's what's so fascinating to me. They didn't just start with the chips. They started by solving the physical problem first. So before we get into all the silicon specs, let's zoom in on what might be the most tangible innovation of all, the actual mechanics of how these things are put together. So get this, in the last generation, the GB200, putting together just a single compute tray, that's the sled that holds the GPUs and CPUs, was this super complex manual job. It took a highly skilled technician about 2 hours to do one. With this new Rubin design, that exact same process now takes just 5 minutes. That is an incredible leap. The immediate question is, how on earth is that even possible? And the answer is right here on the screen. It's night and day. On the left, you've got the old way, a nightmare of fragile, hand-wired cables. It's a mess. On the right, that's Rubin. It is a completely cableless, totally modular design. The parts literally click together using these high-density connectors. It's way less like wiring a server and a lot more like snapping together Lego bricks. Just beautiful. But an elegant mechanical solution like that, it's only possible because of the absolutely immense power and integration they've packed into the new silicon. So now let's zoom in on the chips themselves and see what's making all of this a reality. Before we get into all the nitty-gritty specs, just look at this jump. For what's called FP4 and FP8 compute, which are basically the mathematical engines for training and running AI models, Rubin delivers a 3.5 times performance leap over its predecessor Blackwell. That massive increase in compute density is the key that unlocks this whole rack scale idea. And at the heart of it all, we have these two new superstars. On the left, that's the Rubin GPU. It's built on a bleeding-edge 3-nanometer process and has next-gen HBM4 memory for a huge jump in bandwidth. On the right, that's the Vera CPU, which uses NVIDIA's own custom Olympus ARM cores and basically doubles the performance of the CPU that came before it. And the numbers, they're just staggering. The Rubin GPU is packing 336 billion transistors. Its memory bandwidth jumps almost 3 times to 22 terabytes per second. The Vera CPU now has 176 processing threads. And NVLink, the fabric that connects them all, it doubles its speed. Seriously, every single metric here has seen a massive, massive upgrade.
Okay, here's a quick side-by-side. From pure performance to bandwidth to even the power draw of the rack, which, by the way, nearly doubles to 220 kilowatts, every single aspect has been scaled up dramatically. And here's the crucial takeaway. These aren't just numbers on a page. They are the enablers for a completely new way of building and deploying AI infrastructure.
Okay, so let's pull the camera back out again. We have this incredibly powerful, tightly integrated, beautifully modular system. What does that actually mean for the industry? What are the bigger implications of this extreme co-design approach? Well, the secret lies in the technology that makes that whole Lego brick design possible. They're called blind mate connectors. And just like the name says, they join circuits together without a human needing to see or guide them in. But there's a catch, right? To work, they require a level of precision that is, frankly, beyond what a human hand can consistently do. And that leads us to the inevitable conclusion. Because human hands are no longer precise enough, robotic assembly isn't just a nice-to-have, it's mandatory. This shift to a 5-minute automated process is the only way to build these things at scale. And it forces manufacturing partners like Foxconn and Quanta to invest in automation that is tailored to NVIDIA's specific design, which, you guessed it, tightens NVIDIA's control over the entire ecosystem even further. Which brings us right back to where we started. By co-designing everything, the silicon, the mechanics, the manufacturing process, NVIDIA has successfully redefined the fundamental building block of AI. It's no longer about going out and buying a chip, it's about buying a fully integrated compute rack. And so this whole thing leaves us with one final, pretty provocative question. This strategy gives NVIDIA a level of control and integration that is just unprecedented, making it incredibly hard for anyone to compete with them piece by piece. So you have to ask, by turning the entire rack into a single product, has NVIDIA built an unbreachable fortress in the world of AI?